We usually think of induction as changing the magnetic field around a stationary wire. But what if we keep the field perfectly still and move the wire instead? Let's look inside that moving rod. Even though the metal is electrically neutral, it is packed with free electrons. Because those electrons are being pushed to the right through the magnetic field, they experience a downward Lorentz force. As those electrons pool at the bottom, they leave a net positive charge at the top. This separation of charge creates a voltage difference across the ends of the metal. We have effectively turned this inert rod into a moving battery. The math directly mirrors the physical setup. The voltage, or motional EMF, is simply the magnetic field strength multiplied by the length of the rod and its velocity. We can apply this exact same physics to rotational motion. Instead of a single rod sliding on rails, imagine a metallic wheel spinning inside that same stationary magnetic field. Every single spoke on this wheel acts just like our sliding rod to generate a voltage from the central axle out to the rim. The math adjusts to account for the fact that the outer edge of the spoke moves much faster than the inner edge, but the underlying principle is identical. Pushing a conductor in a straight line or spinning it in a circle does the exact same thing. Moving metal through a magnetic field directly and predictably converts kinetic motion into electrical voltage. Now let's reverse the variables. We will hold the wire perfectly still and change the electrical current flowing through it. This brings us to a property called inductance. Think of a heavy truck. Its mass resists any change in velocity. Coils do the exact same thing with electricity. When we close the switch, the surging current generates a magnetic field. That expanding field immediately induces a voltage pointing in the opposite direction. We call this back EMF, and it actively fights the incoming current. It takes physical work to overcome the mass of the truck and build kinetic energy. Similarly, a battery must do electrical work against the back EMF to establish the current inside a coil. That work isn't lost. It is stored as magnetic potential energy. So what happens if we suddenly open the switch to stop the current? Which way will the back EMF point now? Because the coil acts as electrical inertia, it fights the decrease too. Applying Lenz's law, the back EMF flips around and pushes forward, stubbornly trying to keep the dying current flowing. We can take advantage of this expanding and collapsing field by placing a second coil nearby. The changing flux from the first coil spills over to induce a current in the second. This is mutual inductance. It is exactly how a wireless pad pushes power into your phone. Inductance shows that coils act as electrical anchors. They resist any change to their magnetic state, allowing energy to be stored or transferred wirelessly without any physical moving parts. We can combine the physical motion we observed earlier with the geometry of a coil to build something incredibly useful, an alternating current generator. By mechanically rotating the coil inside a constant magnetic field, we constantly change the angle between the coil's surface area and the magnetic field lines. This oscilloscope chart shows the resulting voltage output over time. The voltage peaks exactly when the coil is flat, cutting through the maximum number of field lines. When the coil turns vertical and moves perfectly parallel to the field, the flux change drops to zero, and the voltage zeroes out right along with it. The continuous rotation draws a perfect sine wave. The electricity powering your wall outlets comes from this exact trigonometric relationship. Massive turbines inside hydroelectric dams use falling water to mechanically spin enormous coils inside giant magnets, generating the alternating current that runs the power grid. This concept map shows how all these phenomena trace back to one single physical principle: changing magnetic flux. Slide a rod through a field, you generate motional EMF. Pulse current through a static coil, you discover inductance. Spin a loop, you produce alternating current. Behind all of these equations is the conservation of energy. Electricity is never generated for free. Electromagnetic induction is simply nature's mechanism for converting mechanical work into electrical power.